Hello and welcome to another processing tutorial. This time it's the flying Bat Nebula. This is OSC data taken from a Lake city centre as usual. We have over here on the left 30 minutes of integrated time using an Optilong L quad enhanced data. We're just going to be using this for accurate RGB coloured stars. We're not fussed about the nebulosity here. And over on the right here, this image is 16 hours of Optilong L ultimate data. So that's dual band, it's hydrogen alpha and oxygen 3. And we're going to combine these to make a hopefully good image out at the end of it. The first thing to note is that the orientation is flipped, they don't match. So I'm just going to do a fast rotation, 180 degrees over there, ping that one around. And there we go, that's fixed. Now I'm going to run integer resample to bin times 2 my data. You don't necessarily need to do this. There's an article up on my Urban Astrophotography website about whether you should bin your data or not. I am upsampled, so I'm going to click 2 times down sample on the L quad. That's going to lower the resolution, and then do it for the alt. Lower the resolution, but give a bit of a signal to noise ratio boost. Great. And now what I'll do, which I probably should have done at the very beginning, is make some clones of these images and put them over here in case we need to go back. Next thing is we want to run star alignment to make sure that these two images line up exactly. So I'm going to load up star alignment here, and our reference image is going to be a view, and I tend to use the one that has got the most data in it, looks the best, so that's the alt here. So view, alt, and then the target image is the one that we're going to change so that it matches the reference image. The target image, it's going to be a view again. We're using views because we've got them here already. The view is L quad. And then to run that, we're just going to click on the circle. Once that's done, we should be able to see the new image here. It looks completely dark, but that we're going to run an unlinked screen transfer function just to bring that back. And there we go, we can see it. We don't need the original anymore, we can close that. There's a little bit of a black border around this one. We need to fix that. So we're going to run dynamic crop. We're going to hold down Control to maintain the aspect ratio as we move this, and we want the crop to be just inside the image and excluding the black line. And we want to run this crop, the exact one, on both images. So to do that, we're going to click and drag the triangle over onto the flying bat alt one, and then we can just click the tick and it will run on the image that was selected there. And now these two will be perfectly aligned. The next thing I like to do is run image solver, which is via script, astrometry and image solver. If you're using an astro camera, then all this information should be filled in already. So I'm just going to click OK. What this does is it embeds lots of useful information about the image into the file that PixInsight can call upon at a later date when we get to different processes where it needs that information. Once one is done, let's do the same thing for the other. Now we want to remove the gradients in the images. This is you can actually see it most prominently on the L quad data. You see it's lighter in one corner, darker in the other. You can see it a bit here in the flying bat of the alt, lighter in the bottom left, darker in the top right. These gradients are a right old pain, especially from cities. We tend to get worse gradients because of the light pollution that we've got. But there's an easy way to fix them, and that is using a free plugin from SETI Astro called Automatic DBE, and DBE is dynamic background extraction, and I'm just going to leave everything on the default here and click execute. There we go. If we're curious, we can see the gradient that it removed. We don't really need that image, so we're going to close that. Let's give it a little stretch so we can see, and then we don't need the one back there. And now let's run the same process on the alt data. So that's script, SETI Astro, automatic DBE, execute. Let's have a look at the background. Yeah, that looks fine. And then we have our alt data that's had the gradient removed. Alright, looking good. I think that we should, let's just rename that L quad just to keep it a small title. Make a clone of that. The next thing we're going to do is a bit of deconvolution. This will sharpen up the images a bit. And the best tool, or the one that I like to use, is Blur Exterminator. Now with Blur Exterminator, there is an option to automatically calculate the PSF. PSF is the point spread function. It's kind of how blurry the image is. But I personally find I get a better result if I use a free plugin here within Render, PSF image, and then I calculate it manually. Once it's analysed the data, we want to look for the two full width half maximum values, the X and the Y, and we calculate what's roughly in between the two. So that would be about 1.79 or so. We remember that number. When we load up Blur Exterminator, we're not using the automatic, we are putting in 1.79. I tend to keep everything else to defaults, but by all means play about with those, see what results you get. And then I'm just going to run that, and it'll only take a moment. That's sharpened up the image a little bit. It is subtle, it's hard to see. If you zoom in a bit, then you can, but it does help. Right, next let's do the same process, but for the alt data. So we're going to run PSF image here. Between the two would be 1.47, so we're going to remember that. Let's put in 1.47 here, and then run that on the alt data. That's all done, looking good. Right, what should we do next? I think it's time to stretch the L quad and take the stars out. So I'm just going to put the ultimate there for a moment. So we want to stretch this data. To do that, we're going to go to Astro again and do a statistical stretch. Let's preview this. Play about the sliders until it looks how you want. Remember, we're only interested in the stars here. Oh, hang on. I haven't changed the colours, have I? I almost missed that. Alright, we need to do the colours before we stretch. So, to do the colours, we're going to run a colour calibration tool called SPCC, which is spectrophotometric colour calibration. As a required step within this, we're going to want to tell the function about where the background is in our image, so it can neutralize it. Easiest way to find background, Astro again, thank you Astro. We go to find background, click search, and then it'll make a little preview of where it thinks the background is. So back to SPCC, we're going to click on region of interest from preview and background, and then run that, and it should whiz through, make the colours a bit more accurate, and give us a little graph out of it. Okay, looks good. Let's right click on that, delete the background. There we go. Right, so that's our colour calibrated L quad data, and then let's do the same thing with the alt. So we're going to go to Astro, we're going to go to find background, we're going to click search. Okay, we've got our background. This time though, we are using narrowband data, so we're going to click narrowband filters mode, and it's an L ultimate which has bandwidth of 3 nanometers, so 333. Important note I always stress to make when I use this tool with this kind of data is that SPCC is not designed to be used with dual band data like this, opt long L ultimate in this example, but I find that it works fine, so I just use it. Okay, all looks good. Region of interest, we're going to select that background and then run it. There we go, colours, looking good. Now we'll go back to the stage that I was saying. Oh, actually, I'll tell you what, we should make clones. In case we mess anything up. Now the next step is to stretch our data, because currently it's linear, which means that it's actually almost black, these images. That's why we're having to use the screen transfer function to see what's going on. But we're going to stretch it. We're going to go to Astro, we're going to go to statistical stretch, preview. I like to give the curves a bit of a boost so it's a bit contrasty, and it doesn't need to be too exact with this image because we're just interested in the stars, so let's just go with that. Stretch, stretch, stretch. Now just put the alt out of the way for a moment. So what we want here is just the stars out of this image. So the best way to do that is we're going to make a clone, and then I use StarNet 2. We've stretched our data so it's not linear, and we're going to make an image that has all of the stars removed, which seems like an odd step because we want the stars, we don't want them taken out, but this is just a precursor to the next bit, which is using Screen Stars here, which is a free plugin, and it's really, really good. So we want star removal. The star review is L quad. The starless view is L quad clone 3. And then let's click OK. And ta-da! Just the stars. We don't need that anymore. We don't need that anymore. I personally like to give the saturation of the stars a little bit of a boost. So in order to do that, I'm going to use color saturation. Click on the circle for a real-time preview. And then just to give a bit of a global boost to the saturation, there's a tiny little yellow dot here. I'm going to click and drag that up almost to the top, and then click on the square to activate that. Close that, close the real-time preview, and here we have our stars that have had their colours boosted a little bit. A bit more pleasing to the eye in my opinion. Now we can minimise that, and we'll only come back to the stars at the end when we want to put them back into the final image. Now we need to work on the alt data a little bit, and to do that we're not going to stretch it in the normal way. Instead we're going to go to another SETI Astro tool, which is Perfect Pallet Picker, and what this is going to do is give us a range of options of palettes from our dual band data. So ultimate is a hydrogen alpha and oxygen 3, so we want to put in the alt there. It's alt because that's the one that we're working on. It's still linear. Let's click create palettes, and then we'll have lots of options, and we'll choose what we think looks good. Most people go for the HOO. I quite like the 4-ax for this one. So I'm going to click on 4-ax and then close this, and hey presto, we have a 4-ax image. So minimize that, put it out of the way. Let's make a clone of that, put that over here, and we can do a little bit of work on this. Well, actually what we want is to take the stars out. It's not linear data anymore. We're just going to remove the stars because we don't need these stars. These are narrowband stars. We're not so fussed about them. We've got some RGB stars that we're going to put in at the end. Now there are all sorts of lovely things that we can do to this image. Let's have a think. It's a little bit noisy, so I'm going to apply some noise exterminator. Let's say 0.7. Run that to fix a little bit of that noise. Alright, that's looking nice and smooth. Let's do a little bit of curves transformation, shall we? Just to give it a bit of a contrast boost. Okay, and now perhaps a mask so that we can work on the background here, because I want this to be a little bit darker without affecting the main part of the supernova remnant here. So to make a mask, I'm going to use range selection and create a little real-time preview here. And what we want is the supernova remnant. To see that, let's increase the smoothness. Okay, that's probably alright. Click OK on that. And then we have our mask. Let's apply that by clicking and dragging it and putting it under the name of the image. And it appears red to show us what we'll be working on. We don't need to see all that red, so we can click on the little toggle here, which will make the mask appear to go away, but we know it's still on because this button here with the green tick is checked there. So let's go back to curves, and this time I always get it the wrong way around. So this mask is set for the supernova remnant, not the background, and I want it to be set for the background. That's alright. I always make the mistake. We can invert it very easily. And then go back to curves. Then this time we'll darken the background, whilst leaving the main nebulosity here unaffected. Okay, let's go with that just for now. Let's uninvert that so that we're just working on the nebulosity, and maybe we'll give it just a little boost. And then perhaps we'll run a little bit of unsharp mask just to sharpen it up, not too much. Before, after, before, after. You might not be able to see on your screen if YouTube has compressed this, but that sharpens it up a bit, so I'm going to click on the square to activate that. And now this video is going on for a bit long, so let's speed ahead and make a little clone of this, and we're going to work some magic with the colours in the image by using Toolbox Selective Colour Correction. I've explained how I use this in previous videos, but just to briefly recap, you can choose what colour you want to modify, and then you change these sliders, and you actually see what happens in pretty much real time. So I'm just going to go ahead, and I think I'll change the blue channel to try and bring out some colours here. I'll pause the video, I'll make those changes, and then you can see what results I got. In the end, I decided to go for a bit of a purple hue, because I don't often see that in astrophotos, and I did that by taking the cyan down 30, the yellow down 10, boosted the red 50, took the green down quite a bit, the blue up quite a bit, and then you can see how here I tweaked the luminance, saturation and contrast. Now once you're happy with it, you have to click apply, and then you can go ahead and change the next mask. For this, I think I'm going to do red next, and again I'm just going to go through and play about with these sliders. And this is what I settled with. I think a nice kind of deep red here to contrast with the purple, quite a bit of contrast in it, and you can see all the settings that I've used here. And I'm going to click apply, and then that should do it. Alright, looking good. I think what I'll do now is just skip to putting the stars back in. So I'm going to go to Script, Utilities, Screen Stars. And we're not doing star removal anymore, we're doing star replacement. So our starless view is this one, Final Thorax. And our stars view is stars, which is the one we made earlier. I'm going to click tick on that. And hey presto, here we have our image. Almost done. Just as a final step here, I'm going to use integer resample to get our resolution back. So starry, this time I'm going to upsample. And then if you wanted to, you could also do a dynamic crop if you wanted to move in on the main point of interest around about here, for example. But I think that's enough for now. Thank you very much, and I hope you found that useful.